Good morning, my friends. I'm Clover, and this is Genuinely Approachable Sudoku, and today we are solving Half by Philip Newman. This is a ratio pairs Sudoku. That means we have standard Sudoku rules, so we're placing the digits 1 through 9 once each in each row, each column, and each outline 3x3 region. And on top of that, we have some black dots in the grid. And everywhere you see a black dot, the two digits adjacent to it have to be in a 1-to-2 ratio, meaning one of them is twice as big as the other one. So there are only a few ways to actually do this with Sudoku digits: 1 and 2, 2 and 4, 3 and 6, and 4 and 8. So that's going to limit which digits we can even put on a black dot. In fact, a couple of these are very limited already. So if we have 3 in a row, that has to be either 1, 2, 4 or 2, 4, 8. So we can go ahead and mark that as some combo of 1, 2, 4, and 8, and there's always a 2 or a 4 in the middle. In this region, we've already used 1 and 3, so this is either 2 and 4 or 4 and 8. Then that means it definitely has a 4 on it. In this region, we've used a 3 already, so the only 2 remaining that we can put in here together are 1 and 2 and 4 and 8, which will go like that. And that can't be 1 and 2, therefore this triple is increasing, so that is a 1 or a 2. In here, we can't use a 1, so one of them has to be either 2 and 4 or 4 and 8, and then the other has to be 3 and 6. But we've already used 2, 4, and 8 in this column, so this must be the 3, 6, which goes that way around because of the 3 in column 2. And then this contains a 4. That means there's nothing else we can put in these two cells other than 3 and 6, and now this is some combo of 1, 2, 4, and 8. But we can eliminate 1 from both of those cells, and we can eliminate 4 from here. Therefore, this is either 2, 4 or 8, 4. Either way, that's going to be a 4. Now, if we look at this guy, it doesn't have a 1 or a 3, so it's either 2 and 4 or 4 and 8. Either way, it's going to have a 4, and that cell is not going to be a 2. That means if we look at this, we can't use 1, 2, 4, or 8, so it can't be 1 and 2, can't be 2 and 4, can't be 4 or 8, so it must be 3 and 6. Therefore, this is not a 3, 6 pair for a couple reasons. This cell can't be 3 or 6 in column 2, and also if we made it a 3, 6 pair, it would break this cell. There'd be nothing left to put here. So it is some combo of 1s, 2s, 4s, and 8s, and this cell is not a 1 because we already have a 1 in this column. We can't have a 3, 6 pair here because, again, it would break this very powerful cell, row 7, column 4. So these are a 1, 2, and a 4, 8. We've already definitely used 2 and 4 in these 3 cells, so that's a 1 or an 8. That means this is either 1 and then 2 or 8 and then 4, but because there's a 4 there already, we know it's 1 and then 2. That resolves this. So now if we go over here, this doesn't have a 1 or a 2, but it's also not 4, 8, so it must be 3, 6. So these are from 1, 2, 4, 8, but there's not a 1 or a 4 here because we've used those in the column already. So this has to be a 1 or a 4. Now we're going to look at this guy. This can't be a 4, 8 pair. It can't be a 3, 6 pair because this cell can't be 3 or 6. In fact, this cell must be either 1 or 2. Therefore, this has to be 1, 2, or 4, but because we've already used 2 and 4 here, because this is either 1, 2, 4 or 2, 4, 8, this must be a 1, making this a 2. That resolves this, which is going to bounce back and resolve a lot of these. Now, because that's a 2, this becomes an 8 and a 4, so we can eliminate 4 and 8 from these cells, and that's going to resolve the order here. The 4 there will also give us an 8 and a 4 here. This pair can no longer have a 2 or a 4 in it, so it's 3, 6, and that gives us the order of these. And that's all we can easily do right now without looking at some of the digits that aren't on black circles, so let's go ahead and do that now. So my last 2 digits in this column are going to be 5 and 7. My last 2 digits here are going to be 5 and 6. I have a 6 in region 1 already, so that'll go there. That resolves the order of this 3, 6 pair. Here I'm going to need a 7, an 8, and a 9, and this can't be an 8. In this row I need a 5, a 7, and a 9. This can't be a 9, so I have a 5, 7 pair here, giving me a 1, 2 pair right here. I need a 6 in one of these cells, and there's already a 6 in column 4, so that's a 6, making this either a 5 or a 7. And because there's a 7 in the row, that's a 5. This is now a 5. That's a 7. This is a 5. I need a 1 in one of these 2 cells to finish off the row. That'll go like this. I have a 6 here. That resolves the 3, 6, and my last digit in column 5 is a 5. So this is either 7 or 9 to finish the region. Here I need a 2 and a 6 to finish the row. That resolves like this. Now I need a 7 and a 9 right here. That's 9, that's 7. To finish column 8, we're going to place an 8. Now we need a 1 in this region, and then a 5, 9 pair, or not a 5, 9 pair. Where have I gone wrong here? I've missed out a 5 somehow here. Yep, that's going to be a 5. Oops. That's a 7, and here I need a 1, an 8, and a 9 to finish this region. So that becomes my 8, my 9, and my 1, based on what I already have in rows 4, 5, and 6. These will be 5, 7, and 9. These are going to be 3 and 7 to finish off this row, and because I have a 3 in this region, that's my 7. And this now becomes a 7, making this cell a 9, and making this a 5. I have a 7 here, which resolves this into a 9 and 8, and also resolves the 5, 9 pair. And I can resolve these 7s and 9s kind of bouncing around the grid here. My last digit in this region is going to be a 6. These will be 3 and 4 to finish the column, which resolves the 4, 8 pair. And now I need a 5 and an 8 to finish the grid. And that is how you solve Philip Newman's half. I really enjoyed that one. I hope you guys did too. The link to solve it yourself is in the description of this video. And I will see you again in 3 days.